one common trend that we typically investigate is something called an isoelectronic species. And an isoelectronic species has the same number of electrons for everything involved in this comparison. So if we look at calcium 2 plus, potassium plus, argon, chloride minus, and sulfide 2 minus, we see that each of these have a different number of protons but the same number of electrons. So what we can look at here is how the protons in the nucleus will influence the electrons surrounding the nucleus. And there's going to be a force of attraction between the protons and the electrons. So the more protons in the nucleus, the greater attraction, and the smaller the radii. So when we look at some elements arranged, we first need to figure out how many protons and how many electrons they have. If everything has the same number of electrons, we have a benchmark in which we can arrange these in a particular order. So the smallest in this series is going to have the one with the most protons. So if we look at that, we would see calcium 2 plus has 20 protons. The largest is going to be the species with the least number of protons, which is the sulfide. And the order in which these are arranged is in increasing, the increasing radius is in order of decreasing number of protons. So we're going to have calcium 2 plus followed by potassium plus, followed by argon, followed by chloride, followed by sulfide. So sulfide is going to be the largest in this particular species. Okay? And we note that all species have the same number of electrons, but we order them from, in terms of smallest over to largest. The smallest has the greatest number of protons, whereas the largest has the least number of protons. So we can do the same exact thing if we compared magnesium 2 plus, neon, and sodium plus. So if we wanted to arrange these from smallest to largest, we first have to look at the number of protons and the number of electrons we have. Magnesium has 12 protons and 10 electrons. Neon has 10 protons and 10 electrons. Sodium plus has 11 protons and 10 electrons. So we see that this is an isoelectronic series where each of these have 10 electrons. So the smallest is going to be the species with the most number of protons, which is magnesium 2 plus. Second is sodium plus, and the largest is going to be neon. So this is how we would investigate and analyze isoelectronic species and put them in order of the radii.